number 7 says, a rectangular page in a textbook has an area of 100 square inches. Top and bottom margins are set at 1 inch, and left and right margins are set at half an inch. The printable area of the page is a rectangle that lies within the margins. What are the dimensions of the page that maximize the printable area? So again, the last sentence usually tells you what you're trying to maximize or minimize. So in this case, we're trying to maximize the printable area. So I'm going to have A is equal to, and it's X. If you look over at the picture, X is the entire distance across. So to get the distance across the printable area, or this distance from here to here, then you would have to take X and you would subtract 0.5 twice. And we're going to multiply that by, because we're trying to find an area, y minus, again, y is the entire length. So to get this length right there, you would need to subtract 1 twice, so the top and the bottom, in order to get that. So this will be y minus 1 minus 1. So let me put this as x minus 1 and y minus 2. If you can see that from the start, then you can just put that. And we run into our issue that we've been running into on every problem here, where we have too many variables. So I need to find out some more information, or use some more information about the function in order to get only x's. So the area, not the printable area, but the actual entire area of the page has to be 100 square inches. So x times y, I know, has to be equal to 100. So y is equal to 100 over x. And this is the information that I'm going to use in order to make my equation in terms of only x. So A is going to be equal to x minus 1, and then instead of putting y minus 2, I'm going to put 100 over x minus 2. Then I want to FOIL this. So A is going to be equal to x times 100 over x is 100. Negative 2 times x is negative 2x. Negative 1 times 100 over x is minus 100 over x. And then negative 2 times negative 1 is plus 2. So A is equal to, I'm going to call this negative 2x and minus 100 x to the negative 1. Instead of writing it as 100 over x, I'm writing it as x to the negative 1 plus 102. So this is my original equation. So my next step is going to be to take the derivative. So a prime is going to be equal to negative 2 plus 100 x to the negative 2, and I want to set this equal to 0 to get the critical numbers. So I have negative 2 plus 100 over x squared is equal to 0. And I'm going to solve this one a little bit differently than we did before. So on one of the previous problems we got a common denominator. You can still do that here. I'm actually just going to add 2 to both sides to get 100 over x squared is equal to 2. And that's actually 2 over 1. So I'm doing that because that allows us to take the cross products because it's a proportion. So we can say that this is 2x squared equal to 100, or x squared is equal to 50, or x is equal to plus or minus the square root of 50. Now, both of these are critical numbers, but only the positive one makes sense because we're talking about dimensions here. So only the positive square root of 50 makes sense. So we still need to do the proof. So the square root of 50, and if you plug these into the derivative, this will be a positive and this will be a negative. So we have proven that this is indeed a maximum. Again, without this proof, we don't know if it's a max or a min or something else. So this really proves it. So there's a max at square root of 50, which is x. And then if you wanted to find the area, which they don't really ask for technically on this one, but you could, then you would want to plug that into the original. And then you would get 73.72, but again, they don't really ask for it. At least not on this particular problem. They technically want to know what are the dimensions of the page that maximize the printable area. So I still need y, because I have x, because they want the entire page. I still need y. So I'm going to go over to where I defined what y is, and I can plug in the square root of 50. So 100 over the square root of 50, which that would be an exact answer. So this is okay. Or 14.14 if you get the decimal. So the dimensions are square root of 50, and this is inches by 14.14 inches. And if you want to use the 7.07 instead of square root of 50, that's fine as well. So this is going to be your final answer.